Welcome back to Kafka Big Picture for Beginners. So, you are now familiar with Kafka ecosystem and learned some basics about all 5 components of Kafka. The next question is this: when to use what? And what kind of solution is being developed using the Kafka ecosystem components? Basically, we are seeing 3 patterns: data integration pattern, real-time stream processing using microservice architecture, and real-time data warehousing pattern. The first pattern is to focus on your data integration problem and solve it using Apache Kafka. In these scenarios, you may have a bunch of independent systems. They serve a specific purpose, generate some data, store it, and own it. However, they also need to send or share some part of the data with other systems. So, if you are solving a data integration problem using Kafka, then you are going to use combination of the first 3 Kafka components: Kafka Broker, Kafka Client APIs, and the Kafka Connect. The Kafka Broker is going to give you a shared data bus-like infrastructure. Whoever wants to share data with other systems will be sending data to the Kafka brokers. All other parties which are interested in that data will consume from the Kafka broker. And this architecture gives you following advantages. If you are working with custom or bespoke in-house applications, then you are going to use Kafka Client APIs and implementing embedded Kafka producers and consumers. However, if you are working with standard commercial off-the-shelf products, then you will be using Kafka Connect. What if you cannot find an off-the-shelf Kafka Connect connector for one of the COTS application? You should be using Kafka Connect framework to create one, rather than using raw producer-consumer APIs. The most common scenario to see this kind of implementation is in data lakes, where you need a reliable and scalable method to bring data from hundreds of sources to the data lake storage. Once the data is in the data lake, you might be using Apache Spark for the rest of the processing. The second and the most prevailing pattern is to create a real-time stream processing application adopting a microservice architecture. In these applications, you will be using a combination of following Kafka components: broker, client APIs, only producers, and Kafka streams. Kafka Broker has the same role in these solutions as well, providing a backbone infrastructure and making data available to all your microservices. These solutions could be using Kafka for 2 purposes: creating streams and processing streams. You would be using Kafka producers for creating streams. However, if you need to create a stream that is sourced from some COTS applications, then you might be using Kafka Connect. But the Kafka Connect may not apply to the microservice. And all of them will be using embedded Kafka producer to share data with others. Similarly, you will be using Kafka streams for implementing your business logic and achieving your real-time stream processing needs. Kafka consumers are not fit for that purpose, and they lack most of the capabilities to handle stream processing requirements. And also, everything that you can do with Kafka consumers is doable with Kafka streams more easily. So, you are not likely to use Kafka consumers. The third pattern is relatively new and evolving. The idea is to make a real-time data warehouse. So in this pattern, like a data warehouse, you are going to collect data from a bunch of source systems into Kafka cluster. Most of these sources are likely to have a database backend or a REST interface. For example, your OLTP systems are likely to have a relational database. And many of your cloud-based applications such as Salesforce is going to have a REST interface. So, you will be collecting data from all these sources to your Kafka cluster. And obviously, you will be using Kafka Connect. Once your data starts coming to the Kafka cluster, you are going to use your Kafka cluster as a data warehouse. In this pattern, you will be modeling all your workload and reporting requirements using KSQL and run them on KSQL server. The KSQL is going to generate a real-time report which keeps refreshing every minute, second, or even in milliseconds. This notion is relatively new and evolving, but if such requirements are modeled correctly, they can bring a lot of quick and compelling solutions to the business. The data warehousing and the data lake implementations always aspire to achieve a state where they have the most recent information and reports to make the right business decisions. However, the most recent has always been a few hours old, and in some cases, a day or even older. Kafka and KSQL are moving towards offering a real-time solution. Everything in real time is not at all possible, but a lot can be achieved with a careful design. So, you might see that in coming days, Kafka plus KSQL starts challenging data warehouses and data lakes for their real-time workloads. Among all these three patterns, the first pattern is mostly implemented in data lakes. The second pattern is most prevailing implementation these days. The third pattern is evolving and needs to pass the adoption test. If you are a Java guy or a microservice architect, your Kafka focus should be on the following three things: Kafka broker and internals, Kafka client APIs, producer APIs, Kafka streams. I already have a full-fledged deep dive masterclass covering all this. Check out my other courses. If you are a DWBI professional, then your Kafka focus should be on the following things: Kafka broker and internals, Kafka Connect and commonly used connectors, and finally the KSQL. Check out my other courses for deep dive into these areas. Great! That's all for this lecture. See you again. Keep learning and keep growing.